Welcome back to Pre-Algebra. We're in section 2 of chapter 3, which is adding and subtracting with decimals. And after that last section of teaching about naming decimal numbers, you'll love this. You already know how to do what we're doing in this section. But first, what can go as fast as a racehorse? Well, the jockey, of course, can do that. So how do you add and subtract decimal numbers? You do them pretty much the same as you would whole numbers. If you have 24 plus 16 plus 204, you want to add those up vertically. 24, 16, 204. What you've actually done without knowing this is you've made sure that our place values are lined up. We have the units lined up, the tens lined up, and the hundreds lined up. And it happens to be that 204 is the only number here that has a value in the hundreds place. You would never say 24 plus 16 plus 204 and come up with a value of 604 for this. Now would you? Because you intuitively know, and by practice you know, that you add your ones, you add your tens, you add your hundreds. So your true number here is 1014. This is what happens when you're not aware of place value. This is what we talked about last section, where the value of that each digit has is determined by the place value, by the position of that digit in your number. Here, we're adding this 24 here as if the 2 were in the hundreds place, and it's not. So, having shown you this, how do we add decimal numbers? How do we know how to line up decimal numbers? Because what we've been comparing before is we know that we don't have the same 17.3 plus 16.42 plus 7.036. How are we going to line these things up so that we make sure that our place values are tens under tens, hundreds under hundreds? What we're going to do is line up the decimal points. So this would be 17 and 3/10. This would be 16 and 42 hundredths. This would be 7 and 36 thousandths. As long as you have your decimal points lined up, you have structured your addition problem correctly. So we're going to add these three. And you say, yeah, but we don't have the same number of digits to the right of our decimal point. That's true, you don't. So you can add in placeholders. Your book calls it annex zeros. I've never heard it called annexing zeros before. 42 hundredths is the same as 420 thousandths. 3/10 is the same as 300 thousandths. So if you need to go ahead and add your zeros in as placeholders, you sometimes do this when you began to learn how to multiply 2 or 3 digit numbers. You'd add zeros as placeholders. That's all we're doing here. 6, 2 plus 3 is 5, 3 plus 4 is 7, there's your decimal point. 7 and 7 is 14, and 6 is 20. Gives us 40 and 756 thousandths. Tenths, hundredths, thousandths. So you read the portion of the number to the right of the decimal as if it were a regular whole number, 756, and then you call the name of the last place. This is very straightforward. What about if we're subtracting a number? How about 157 and 26 hundredths minus 39.825. How do you technically speak 39.825? 39 and 825 thousandths. We're going to subtract these two. 157.26 minus, we're going to line up the decimal points, 0.825. Add in a 0 there as a placeholder. Do your subtraction. 533,711. Let me see if I even did that right. 5 plus 5 is 10. 5, 6. Nope, I didn't. 4, 7, 5, and 1. See, you can get going too fast. Oh, it doesn't take any time at all to go back and check your arithmetic. So you simply, when you're adding or subtracting decimal points, remember to line up the decimals. Add in zeros as placeholders, or what they call annexing zeros. Subtract as normal. 6 minus 2 is not 3. But it is when you borrow. See why I don't teach arithmetic. 5 plus 5 is 10, carry 1, 3 plus 2, 12, 16, 17, 5, and 1. Do your addition, do your subtraction. Now what do you want to do if you are given a decimal number and they ask you to evaluate for a variable? For example, evaluate y minus 8.48 for y equals 9.2. Nothing mysterious about this. When you evaluate for a variable, take the value that they give you for the variable, substitute it for the y. So now you have 9.2 minus 8.48 that they wish for you to evaluate. That says, give us, you would call it the answer. Find up the answer to that subtraction problem is all it means when they're talking about evaluating. Put this in vertical subtraction, 9.2 minus 8.48. Once again, we've lined up the decimal points. Might make it a little bit awkward to subtract, so you can annex a 0 here as to show us that we don't have any value in the hundreds place. 10 minus 8 is 2. 11 minus 4 is 7. And what you have right there is 0.72. This is something that's a little bit different. When you don't have anything in the units place in a decimal number, 9 minus 8, but we borrowed 1, so it's 0 there. We actually do use a 0 to indicate, to just make it so that this is screaming at us that we have a decimal number. This is 0.72, 72 hundredths, as opposed to maybe when we get in a hurry and we forget to be really careful about our decimal points. Maybe we end up saying that 9.20 minus 8.48 is 72, which obviously makes a bunch of nonsense since you only had 9 to begin with. Or maybe just had something that looks like a little stray decimal point there. That's why with decimal numbers we put a 0 in front of the decimal point. That just screams this is not 72, but it's 72 hundredths. That's all that's involved in adding and subtracting decimals. See how nice it is to have a very quick video? I'll see you next time.